learned linear function. However, not all functional situations in the real world are linear. Just like not all roads are straight. Take a look in the different scenarios of math in action. A basketball coach analyzing the shooting path of his players. An astronomer studying the distance to a star. A policeman measuring the length of skid marks in a car accident. An architect designing a blueprint of a room to maximize the area. And a farmer trying to figure out the number of trees that will produce the greatest number of crops. All these situations are practical applications of math. Now, we have this situation that we have to explore. Here is a table of values. From this, we can identify if it is a function by plotting these points and describing its graph. Consider the values of x, the values of y. The values of y are actually the square of the value of x. What kind of a relation is this? Is this a function? Let us sketch the graph and describe its shape. Here, we have its graph. It is a U-shape. The graph of a quadratic function is a parabola. What do you observe about the shape of a parabola? What are its features? We have actual models or examples in real-life situations where the shape of a parabola is present. See, even in a banana, we can see a quadratic function. A function whose graph is a parabola is called a quadratic function. Its equation can be written in the form function of x is equals to ax squared plus bx plus c, where a is not equal to 0. The highest exponent of the variable is 2. Then it is second-degree function. The shape of a graph of a quadratic function is always a parabola. Here are examples. What is the shape of the parabola? It is a U-shaped. Here, the parabola is wider. This one, it is narrower. What is the direction of the opening of the parabola? It could open upward or downward. It's up and down. What have you noticed? Does the parabola have its lowest or highest peak? There. It's the vertex. It is the turning point of the parabola. Here, the vertex is at its minimum point. This one, the vertex is at its maximum point. The axis of symmetry divides the parabola into two equal parts. We have forms of quadratic function. First, we have the general form, the vertex form, the intercept form. The general form is y is equals to ax squared plus bx plus c. The vertex form is y is equals to a times the square of the quantity x minus h plus k. Each k is the vertex. The intercept form, y is equals to a times the quantity x minus p times the quantity x minus q, where p and q are the x-intercepts, and the product of a times the negative of p times the negative of q is the y-intercept. This time, let us practice determining which of the following equations represents a quadratic function, and later we'll identify the values of a, b, and c. Let's have number 1. The function of x is equals to 4x squared plus 3x minus 1. The highest exponent is 2. Then it is a quadratic function. The value of a is 4, the value of b is 3, and the value of c is negative 1. Number 2. G of x is equals to 2x minus 3x cubed plus 4. Last time, the highest exponent is 3. Then it is not a quadratic function. Let's go to number 3. H of x is equals to the square root of 3 times x squared plus 2. Here, the highest exponent is 2. Then it is a quadratic function. The value of a is the square root of 3, the value of b is 0, and the value of c is 2. This time, we'll be rewriting quadratic function to its different forms. Number 1, we have from the vertex form to the general form. Let's have this example. Y is equals to 2 times the square of the quantity x minus 2 minus 8. Okay, what we are going to do is to square the binomial x minus 2. That will give us x squared minus 4x plus 4. Distributing 2 to the trinomial, this will give us 2x squared minus 8x plus 8. However, we can subtract positive 8 by negative 8. Finally, our general form of the equation is 2x squared minus 8x plus 0. What did we do? We just use the FOIL method or square root of binomial, distribute a, which is 2, and then simplify. Let's have another example. From intercept form to general form. Let's have this example. Y is equals to negative 2 times the quantity x minus 2 times the quantity x minus 3. We are going to get the product of the binomial x minus 2 and x minus 3. So the product is x squared minus 5x plus 6. And then we have to distribute negative 2 to the trinomial. Then we have negative 2x squared plus 10x minus 12. Okay, there you go. What did we do? We tried to get the product by using the FOIL method, and then distribute negative 2, and then we simplify. from general form to vertex form. So we have y is equals to 3x squared minus 12x minus 9. Again, the first condition, you have the coefficient of the x squared term should be equal to 1. This time it is 3. Can we factor out 3 to have 1 as the coefficient of x squared? There, we have to prove x squared minus 4x. And then, take the coefficient of the x term, which is negative 4. And then we have to divide it by 2, which is negative 2. And then, what's next? Square negative 2. That is equal to 4. This 4 again will be added and subtracted at the same time. So there you go. There. And simplifying it, we were forming actually a perfect square, which is x squared minus 4x plus 4, where the factors are x minus 2 and x minus 2. Finally, we have y is equals to 3 times the square of the quantity x minus 2 minus 13. Let us identify the value of a, which is 3, the value of h, which is positive 2, and the value of k, which is negative 13. Okay, this time we are now ready to graph a quadratic function. Let us have to remember first that if the value of a is negative, or that is less than 0, how does it affect the graph of a parabola? And what if it is greater than 0 or positive? We have the general form again, y is equals to ax squared plus bx plus c. If a is greater than 0 or positive, the parabola opens upward. And if a is less than 0 or negative, the parabola opens downward. I hope you remember all those. Here, take a look at the graph. Function of x is equals to x squared. The value of a here is 1. 1 is positive and is greater than 0, thus the graph opens upward. The other function here is the function of x. G of x is equals to negative x squared. This time, a is negative 1, which is less than 0. The parabola opens downward. Okay. How about as the value of a increases or gets closer to 0? How does it affect the graph of the parabola? Let's take a look at this. As the value of a increases, the shape of the parabola becomes narrower. And as the value of a gets closer to 0, the shape of the parabola becomes wider. Here, take a look at the graph. You can see if it is a is 1 over 8, the graph becomes wider. And if it is even wider if a is 1 over 16, and even more wider if a is 1 over 64. Let's take a look if a is 5, it's narrower. If a is 2, and if a is 1. What will happen if we have a vertex form where y is equals to a times the square of the quantity x minus h plus k, where hk is the vertex of the parabola? We have this condition. If a is greater than 0 or positive, how does it affect the graph of parabola? And if a is less than 0 or it's negative, what happens to the graph? Let's have this. Okay, the value of h determines how the vertex of the parabola is translated to the right. it is translated to the right if h is negative, or to the left if h is positive. That is the point of reference, is the point of origin. Okay, take a look at this. The original function here is function of x is equals to x squared, such that the vertex is at the point of origin, which is the point of 0, 0. What will happen if we have this function? H of x is equals to the square of the quantity x plus 2. The h, it will become negative 2. Okay, so what happens here? So from the point of origin, you translated the parabola 2 units to the left. On the other hand, we have this function. G of x is equals to the square of x minus 1, where h here is positive 1. So that should be 1 unit to the right from the point of origin. Okay, I hope you remember all those conditions. How about if we're considering the value of k? What if k is greater than 0 or positive? What happens to the graph? And what if k is less than 0 or negative? Okay, this is the concept. The value of k determines how the vertex in the parabola is translated above, it is positive, or it's below, if it is negative. That is again the point of reference, is the point of origin. Here, take a look at this. So our original parabola is the function s of x is equals to x squared minus 2. So k here is function of x is equals to x squared, where the vertex is at 0, 0. Okay, so if we have this function of s of x is equals to x squared minus 2, you see, because k is negative 2, we translated the parabola 2 units downward. Okay, how about if we consider this function of x is equal to x squared plus 3. So from the point of origin, our point of reference here is the function of x is equals to x squared. So plus 3, the k is 3 there. So you are going to translate the original parabola 3 units up. Okay, so that's it. In summary, if we have this vertex form, y is equals to a times the square of x minus h plus k. Remember, the sign of a determines the direction of the opening of the parabola. Again, if it is positive, it opens up. If it is negative, it opens down. How about the value of a? It determines how narrow or wide the opening of the parabola is. If it is greater than 0, it is narrower. If it's getting closer to 0, it becomes wider. How about the value of h? It will determine how the vertex of the parabola is translated to the right. If it is negative, or to the left, it is positive. That is from the point of origin. Now the value of k will determine how the vertex of the parabola is translated above, if it is positive, or below, if it is negative. Again, the point of reference is the point of origin. Let's have this example now. Y is equals to negative 5 times the square of the quantity x plus 4 minus 6. Okay. The graph of the parabola opens downward because it is negative. Okay. 5, the size of the parabola is narrow. And the value of h, that is actually -4. So it should be translated 4 units to the left from the point of origin. And lastly, the value of k, which will determine the vertex of the parabola, is -6, meaning it should be translated 6 units downward. Here is the graph. So the original function is the function of x is equals to 5x squared. It opens upward, however, it is -5. So it opens downward and it is translated 4 units to the left, there. And finally, it is translated 6 units downward. So we have that green parabola. That is y is equals to -5 times the square of x plus 4 minus 6. Okay, finally, we have this experiment and you will be answering the question, which cooking pan boils the water first? Let us assume that the pans have the same thickness, containing the same amount of water and the same fire source. Okay, it's narrow or it's wider? What is your choice? Okay, thank you for listening and having this video. I hope you learned a lot. Thank you.